Hello. So the other day, I was out at one of the resale shops I used to go to sometimes, but I haven't been to in a very long time because it's 2020. And I noticed this, geez, Aoyue? um, Aoyue soldering station. For only $4, and I thought, I'm just gonna get it because it is very inexpensive, and the enclosure for one I could maybe use. And I also was curious to see how they were doing things. The handle came like this. It's not a cartridge style, but I guess this is the heater and possibly thermocouple in one. Just kind of worried about this shorting out. But anyways, this is just a transformer-based station. I don't know if we can see in here. I'm going to take it apart in a little bit and take a look at it. And see if we can figure out how it works and see how nice it is. Actually, from my the Aoyue will go nicely with my my Yihua, which I actually don't use as a soldering station anymore. I have a soldering tweezers on here, and I just mainly use this as for the hot air now. And then I also have my Aoyue. So the Aoyue will be a nice addition to my Yihua and my Aoyue. So we'll get this open in a minute and take a look at it, and I think maybe before that I'll even fire it up and see if it works, see what kind of display this is. Kind of looks like one of those little OLED displays, but I think, judging from the date code, this is, it looks, I don't know if it's a 2012 or 2011, so, it's possibly 9-10 years old, 110, at least it has the fuse built in there, so it seems like a decent quality station, so we'll just take a look. But if this is a nice silicone, seemingly silicone rubber cord, so I'll keep this at least. I don't think I'll be able to fix this, but I do have a non-cartridge style iron that should most likely fit. I'll have to see, but these are probably very similar among brands, the pinouts and everything. So we'll have a look at that. Oh, look at that. It's actually, oh no, it should be, yeah, it should probably be about the same. Not really sure. We'll find out. Alright, let's have a look here before I power this up. I just plugged it in. It's not on yet. No power to it yet. Just want to make sure we're not gonna short anything out here, which seems, though it may be possible, and I don't know if this had already happened or if this just broke. We have this wire here, and it's awfully close to this spring. Can I remove some of this? Okay, this all comes out here. Let me zoom back out. So this all comes out. Well, that's kind of nice, actually. It looks pretty nicely done, actually. So this PCB up here is all screwed up looking. It's all bent. So I'm not sure how that happened, but yeah, this is cracked. It doesn't look like this spring is making contact with anything at the moment. It is connected to this wire, which I don't know what that means. I think we're gonna try to power it up anyways. Just very briefly. Let's, I don't know if it's on yet, so I'm just gonna give it power. Okay, it's getting 117 volts. Let's just be on the ready to cut the power, but let's see what happens. Is it only on the front? I guess the power's only on the front. Okay, that's an interesting display. I didn't think that was gonna be a 3-digit 7 segment. And looks like it is working as far as I can tell. At least we'll check in a minute, see if this is getting hot. Well, actually I'll just, yeah, that feels like there's some heat coming out there. And this is only set to 200? That's pretty interesting. So, what this is. Yeah, I don't know whoever had this, if they're using it for, this is a sleep function apparently, maybe? So, seems like it still functions. It's a very interesting display. Definitely thought it was an OLED at first. Alright, so that's good. Still seems to work. I think next, let's try my other tip, my other iron with this, see if that works. Alright, we have some tips out here. This is the old handle for the Aoyue, and it looks like it's gonna fit. Let me see if this fits in here. It looks like it. Whether the pinout is the same, well, I think we'll find out because I'm gonna power it up without even testing. And then I'll see if this guy is gonna work. So let's turn it back on. I like the hard switch in the front here, that's nice. All right. Okay, so it's heating. It seems a little laggy at first. Get some solder out here. It's pretty slow, but and let's actually go up to, like, I wonder if this is probably Celsius, I'd imagine, or else it's extremely. Oops, that's a little bit much. Let's go to, I don't know, 330. That should easily melt any solder temperature, and I can smell something getting hot at least. So. Wow, this is quite slow. I'm sure this transformer is just, you know, the iron is probably just sipping on this transformer power. But yeah, this is incredibly slow. I'm sure we can get a lot more out of this, especially with a cartridge type. And I hope the smell that I smell is my iron and not something inside the station. But I'm kind of surprised. I thought maybe a fuse would be blown or something on this thing. So I do also like how it doesn't appear to be just going to around the set point and then staying on the set point, you know, even though the temperature may be varying. It's actually pretty interesting. I mean, there's a lot of averaging going on, I'm sure, but okay, it seems like it's going, yeah. So we're definitely soldering here. Put a little load, it moves. So I like that it's not really totally faking you out with the temperature. So I think that's enough testing. Let's take a look at the guts. Alright, so it looks mainly like there are 4 Phillips screws holding this thing in. I don't know if there were ever rubber feet on this. That'd be nice, but just plastic for now. So Let's see, I think it's just, that's too bad. I'm working on it. I'm gonna use my hand. Alright, screwdriver. Uno, dos, tres. Cuatro. Alright. This is unfortunately right in the area that needs to come apart, so this hasn't been taken apart before. That's kind of good to know. Let's give that a cut. We have this other anti-tamper from the last store. Okay. Well, there's not much in the way of slack here, granted. Let's see if I can make some slack. Zip tie in here, right here. That may give us a little bit more room to work with. Not much. Well, it may. It may. In fact, let's see, I think I'm just going to do this ribbon kind of cable. So we can just pull this out of here. Can we pull this out of here? This board seems to be floating. That's interesting. Okay. Alright, so you kind of detach this top piece here like that. Looks like the control circuitry and everything's pretty much built into this PCB. Most of it, at least. So that's kind of interesting. So can I even get this out of here? That's interesting. Oh yeah, okay. This piece looks like it comes out as well. We'll have a look at that shortly as well. Let's put this down for now. Let me move this back to a different position. So this looks like the power switching board. So we have the digital board with the display. And this is kind of the power switching here. So it looks like we have an MOC 3021, which, if I recall correctly, that's maybe the same chip that was used to isolate and drive the triac in my other station. So let's undo some of these. Let's see, this is a 4. Okay, these are different, so I won't be stuck forgetting what's what. So this looks, you have full bridge rectification. This is a 7806, so 6-volt regulation. Here is going to be your triac, most likely. TY937B. But the part number is actually BT137. I think that's the same triac possibly used in the Yihua for the soldering iron. So that's interesting. So fairly simple. Interesting that it's a 2-board solution. So let's try to get the front board out as well. Yeah, that's just a potentiometer adjustment for the presumably for the heat calibration. So, all right, after a little bit of looking, this actually comes off fairly easily. Let me see. You can see there's these. Can you see? Yeah, there's these clips down here. Why can't we see those? Let me move this light a little bit. You can see the openings for them at least. The angle's not good here, but I think basically what you do is you pry open like this, and they basically just pop out, from what I can tell. So there's the front plate with the circuit board and display and everything. So let's keep going here. I think we can take these apart here. That's not a good time. Okay, so we just have the protective front panel here. That's actually kind of nice. I like the fact that this is actually removable. And then we have double-sided PCB. 2010. So 10 years old now. Not that old, I guess. They're using the LM358, very popular op amp. And then I'll have to look up a couple of these other chips. Oh, look at that. That's an Atmel device. That's pretty interesting. I'll have to see what that is. And then here's the adjustment pot. Looks like it's a 100K. All the push button stuff. And then 3 separate 7-segment displays. So those are most likely going to be driven by this down here, I'm guessing. Alright, well let's just take a look at the digital control board here. The power board's pretty simple. I don't know if we need to really take a detailed look at it. Anyways, we can start with the microcontroller here. It's a AT89C 2051 Atmel. Up to 24 megahertz. Looks like they may be running it at 12. The only thing it is it doesn't look like it has a ADC analog comparator, but yeah, I don't see. I didn't see an ADC when I was looking, so that of course brings us to this ADC right here, which is a TI part, I think. So they're using this to measure the thermocouple voltage, of course isolated, so nice and stable compared to cartridges. And then next, let's take a look at this this chip here. It's the HD74LS247, and this is just a LED 7-segment LED driver. So that's what they're using for these 3 individual 7-segment displays. And then of course you have the LM358 op amp, which is pretty jelly bean. Most people are going to be kind of familiar with that already. So just a lot of standard parts you can see here. Looks pretty nice. I mean, they have a dedicated ADC, dedicated chip driving the display, 20-pin Atmel chip, you know, what you'd expect. This is going to be your op amp circuitry with some adjustable feedback for calibrating the temperature of the soldering iron. So pretty straightforward, I think. So I just wanted to check the AC voltages of the transformer quick. So let's set our meter to AC. Let's set our variac to 120. Okay, we're getting 26 volt on the black wiring. And looks to be about 12 on the blue, which is actually exactly what I thought. So about a 24 volt winding and a 12 volt winding. So one for the black for the digital side and the blue for the iron heat. And then this head leads out to the iron right here. So you're gonna have your power and you're gonna have your thermocouple. Alright, so before we bring this to a close, I thought maybe we would have a look at the triac switching. Well, I have this managed to have this clipped here. Hopefully it won't fall off and sparks will fly. But let's have a look at the scope. Zoom in a little bit. There we are, that's okay. Alright, so I'm going to turn the power on and I think it's ready to go. Yep, set for 200. Alright, let's adjust that. Okay, so look at that. It's actually pretty full power right there. So it's getting pretty much everything from the transformer at the moment. The track's fully open. And then as it gets up to temp, it's actually, okay, so it's 200 now, so it's actually over a little. So basically just regulation once it's up to temperature. Alright, so just another look at the board. We noticed using the triac, they have some phase control that they're applying. But also if you're doing that, you need to have some 0 volts detection, so you can properly turn on and off the triacs. So same with the last station, the 898D that I did a partial teardown. I didn't really look into the 0 volt switching that I'm sure they, or 0 voltage detection that I'm sure they have employed in some way. So in this station it looks like, let's have a look at this board here. This is the in to the control board here. This is out to the soldering iron, and this is the incoming power from the transformer. So you have the 24 volt winding and you have the 12 volt winding. Here's the triac. So you can see where you're switching one side. Here's the gate of the triac. It is being controlled by the chip. The chip is being controlled by the controller board. And then, okay, so this is out to the soldering iron. So we have the power side, and we have the thermocouple side. So we have ground, and then we have the thermocouple input here, or output, I suppose. And so we have ground, thermocouple, ground. This is this is the control chip behind here. So we're turning on and off the triac with this line here. This line looks to me as though it's an input line to detect 0 volts. So when we know when to switch the triac. So if you have a look, we have power here. This is the low power side, and you can see this trace goes through this diode here, and then some capacitor, resistor, and And it goes through this resistor here and into this trace here, this pin header right here. And then this is power. Then it comes in, it actually goes through some circuitry and it goes into half of the op amp here. So it appears as they're using half the op amp to amplify the voltage for the ADC, for the microcontroller, and half the op amp to do some 0 volts detection. So that's how they're doing that. So let's have a look at the input to the ADC and see what kind of op amp voltage we're getting, or the output of the op amp. All right, we're clipped on to the first op amp output, which I believe was the 0 crossing detection. So hopefully I didn't short anything out. Hopefully nothing is wrong. So I'm gonna start it up and we're gonna see what we see on the scope. Okay, so far so good. Look at that, it's looking good so far. Let's change this a little bit here. Look, look at that. That looks beautiful. So that is the 0 crossing detection. It's being done with the 358. So it looks pretty good. I mean, we could verify that, but oh well. Hold on. Let's look at the timing of it. That's an easy way to verify it. So let's see. So let's zoom in a little bit more. And you know what? Well, just rearrange these guys to. Oops. All right, so we're at 8.3 milliseconds. So yes, this is the 0 crossing detection. Let's see how quick they do it. So they do it in 860 it's high for 860 microseconds, which is fine. It'd be interesting to see the whole wave and see exactly where they're triggering. But yeah, it looks like it's working pretty well. So I didn't even think of that. I wonder if with the 890 8D they're doing something similar to that with one of the op amps and I just didn't notice. So maybe I have to take another look at that as well. So, all right, now let's look at the second op amp output. All right, now we're hooked up to the other output of the LM358. This should be the thermocouple, I believe. So the iron's still probably a little bit hot just because we had it on. But let's change this from 2 volts to 1 volt per division, and the timing we'll see. It's probably just fine. It's a gradual increase anyways. So hopefully nothing shorted out again. All right, so we have initial jump, 70, 80. So you can see it's rising. So that's feeding the ADC, and it looks pretty nice. Let's zoom in a bit more. Oops. See if we can get a better look at it. So let's see, what am I? I'm 200 millivolts per division. It's fairly stable, actually. So, fairly stable op amp voltage. Now we're 100 millivolts per division. It's looking something like less than 50, maybe 20 millivolts per division, voltage or noise. So that's pretty nice. Let's increase to, I don't know, 250 maybe. What are we at? We're at 274. Is it creasing? Are we going to be off the screen? Yeah. Oops. Oh, no. There we are. Well, it's off the screen somewhere. Okay, there we go. So, seems pretty good. I think there was a little overshoot, honestly. So, I mean, the controller seems to not really to lie to you too much. The screen doesn't. It doesn't exactly, doesn't just tell you what your set point is and, not show you any variance. It does show some, so that's pretty nice. So, I think that'll wrap this up unless I do some sort of modifications to the station to be able to put on a T12 cartridge. So, thanks for watching.